Okay, so we're going to expand our area formula for a regular polygon. We've seen this before, 1/2 the apothem times the perimeter, but we've really only done it for polygons where we had a nice central angle, so using our 30, 60, 90 triangle. We're going to look at one where I have an octagon which has 8 sides and the perimeter of 80, which means the side length has to be 10. And so we do the same thing as before. We divide it up into triangles where that becomes 360 over 8 or 45 degrees. And then I have to take half of that, and that's where the things get a little tricky because this is 22.5 degrees and we don't have a special triangle with that angle, so we're going to have to use trig to do that. Our 10 gets divided up into 5 and 5, and if we pull this triangle out over here, we can see that we have from 22.5 the opposite and the adjacent. So from 22.5, 5 is opposite, A is adjacent, so it's opposite over adjacent, or 5 over A. And now it's just a calculator problem. I know that A is 5 divided by tan, 22.5. I plug into my calculator, and that gives me 12.1. So I plug that back into my formula, and that's going to give me my area for my regular octagon, in this case, using my trigonometry. Okay, we also have a new formula for the area of just a triangle. And so this again uses trigonometry, and what it does is it expresses h in terms of this angle A, and it becomes, we use c, so sine is h over c, opposite over hypotenuse, and then we make a substitution into 1/2 base times height, which is our standard formula for a triangle. Now we have to be careful, just like if I have a triangle, normally I'd have 3 heights, 1 for each side. I have 3 ways this could look, and A, B, and C are relative. So what that means is if I'm looking at angle A, B and C are the sides. This could also be angle B, or this would be A and C. If this was angle C, this would be A and B. And so we have to be a little bit careful of how this works. It's not always angle A, it's just the relative pieces. But what that allows us to do is find our area the different ways. And so these are the different ways it could look, right, if we just were to list them out with angles A, B, and C. And that allows us, when we have side angle side, to determine our area. So again, that's what this is looking like. It could be any of those 2 sides. It just has to be the included angle as we go through it. We can see that's what this is looking at as we go through it, right? There's the included angle with the blue, the green, and then finally the yellow. Any of those will work. So let's look at a quick example from your classwork. We have a triangular park where 2 sides measure 200 and 300 and form a 65-degree angle. So this again is going to be side angle side. If we draw a picture, there is our picture, there's our included angle, and if we want the area, we have to think about how could I use my new area formula for a triangle. And so area is 1/2 300 times 200 sine of 65. So I could call this angle, if I wanted angle A, this is B and C, that's fine if I want to do that, but I just know it's the sides and the included angle is what gets thrown into my sine function. As I plug through it, I get 27,189 square feet approximately, because again my calculator doesn't give me an exact answer.